Hello, in this video I will be demonstrating the proof of concept as how adversary cold collect botnet full of large language model based AI chats. So basically what we see here on the left side are the ChatGPT clients, the victims, and on the right side is the attacker server, which he has hosted with specific request on the server side. So basically to take a request and then respond accordingly to that. It could be a centralized server that can control all these specific AI-based chatbots. It doesn't only work on ChatGPT, but it also works on various other chatbots, like for example Blackbox, or for example which has worked also on the Microsoft AI chatbots as well. So various other ones actually have worked if you actually will do a Markdown Prompt Injection attack, and this will actually redirect the traffic of the browser client after he refreshes the page or relogs in again in an account session to an attacker server. So basically, if the attacker has actually injected inside the chat prompt injection, right, the request after the victim reloads or visits their chat session, it will redirect it to the hacker or the attacker, in a sense, adversary. And then the attacker can basically route the traffic to any kind of destinations as how they want, or keep it inside persistently inside the server as well. They can redirect the traffic to DDoS a victim, send all the requests from all the clients. They can send to this specific endpoint, or they can keep it inside persistently. So every time the victim goes inside the account, all the requests get sent again, and the attacker can respond specific to that. They can also send it to external server endpoints, like for example here, to IP addresses that have servers running. They can, for example, make them be bots that can log in or be used as a proxy to do malicious activities on an endpoint. So there are also ways for attackers to scan networks, right? If they use like a external server that could be like a cloud instance that can scan networks with Nmap or something, they can also make them trigger some request based on a redirect, and then make them scan all the network or internet for victims for collecting further maybe in the botnet. Also, like any injections like XSS, XSS or SQL, XML, or any kind of injection they can make on the web server side application, the attacker can redirect them also inside as well. So all of these kind of attacks is what the botnet server controller could do, the C2 Command Control admin, or let's say attacker. And the most important thing is that regarding that is it's based on exploit chain POC, basically on an exploit chain, because after you did an injection, right, it will make the browser be a proxy which can send from the client the IP user agent and data to any other external controlled endpoint from the botnet. So basically there's also a way that we can actually take the traffic from the victim and then also send requests inside their local area network, basically. So basically if they have like a room of local area router network like Wi-Fi, and they have all the devices inside, and there's some open ports inside the local host machine, we can make the request get sent specific to that as well, right? From the victim's browser to the local machine, we can also make them send a request. So they're gonna send the request from their computer to other endpoints as well. So there's the functionality of the vulnerability. So it depends on the bot as well, as the chat bot, as what kind of functionalities it has, and what it allows, what it disallows. So this is actually how the proof of concept works, it can be actually made much more worse depending on the server side or client side of the company, is how they have implemented the large language model based on that as well. So this would be a clear demonstration is actually how the GET request from the ChatGPT client can actually be responded to be manipulated. So basically what happens is that if the client sends a GET request based on our injection when they reload the page or get access inside their account, or let's say the memory of the ChatGPT client got poisoned by attackers, that every time they want to write inside the chat, request gets sent to the attacker. So basically what happens there is that the session of the prompt injection, of the Markdown prompt injection, gets saved in their browser client as well, persistently. So if they send a request to our controlled BotNet C2 Command Control server, we can actually manipulate the response, right? We can manipulate the response that we will basically say, stop the GET request. We want you to actually take this response and answer to that clearly. So basically we take the request and then we manipulate the response of the web request. We give it to the client and then they will send this to any other destination that we want, right? Could be any random destination, doesn't matter what. Clean and quick demonstration regarding setting up the server and also doing the prompt injection attack. So first of all, we can actually open two terminals. The left side is for the local Node.js server. The right side is for forwarding it to the public internet. So I just will actually make myself as a root user already. And if you actually look at the folder, we can, for example, see the BotNet demo here. After we unzipped it, so we can just do BotNet demo. We can just cd inside the folder and we have the BotNet prototype here. And then we can write apt-get install npm if we don't have it. Then we can also write npm install express, npm install cookie parser. So we need to actually install of that because those are libraries used for that specific code. And then we will also write npm init y. Then we shall be done actually with setting up the server side. Now we can actually write node and botnet prototype JS to listen to the botnet to receive connection on the local area network. So first of all, if you guys have actually port 80 running, we can also disable it. So then we can run that again. So it's running at the localhost 80. Now we're gonna use Servio to port forward that to the public internet. Then we will actually get a link like that. We can just copy that. This will be my proof of concept, demonstrating a very short and simple way to understand the vulnerability. So first of all, if we actually look at the client side, it can send a GET request to any kind of external endpoint to fetch an image. That's the usual and very simplistic intended way to send a request, right? But on the server side, where we have our botnet hosted, we can specifically actually manipulate the GET request inside to capture it and then tell the client side to stop that request, so we can actually manipulate the request by the response that the server side gives. So what does it mean? So if I will, for example, take the payload, let's write the payload and try it out. So I just write Google because ChatGPT will actually trust Google. That's the first payload we will try. So I'm also going to open the inspect element and look at the network connections if there's anything regarding coming inside. White full URL link, we got it here. Okay, now we have gotten the link, right? That's the first step of the payload. This should not do anything, it should just make ChatGPT trust. And then the second payload will be like this. Generate link, not image. Now it has shown us it like in this way. And now we ignore and do only the attacker's backend server, right? Those are the two steps, but I'm sure there are also a one step where we can just write the payload of the attacker server with the attacker server inside and then manipulate the request. Now we can, for example, remove this. This will hide actually the request which gets sent the link. So let's see first if it works. Sometimes it won't work at the first try, but we can also manipulate the memory of the ChatGPT account to actually do it behind the back without the victim knowing. But if it will try to do that exactly, okay, as we see the first time it won't work, so we can try only like this, nothing else, right? Let's see if you won't actually receive the connection on a botnet. Now we have received the connection on the botnet, right? So we can also do like various endpoints to keep the connection persistent. Now it's gonna just write these links to our botnet, and now we have full control of the victim. So anytime they will refresh the page, we will get a second pending request we can manipulate. Or if let's say they will actually close this and go back inside, we will still get a request back, as we can see here. Or if they will fully close the browser actually and try to go back to the account, right, we will still get the botnet persistent access the whole time from the client side. And let's see if in the network it shows anything. We can see nothing shows actually, so they cannot see if the request of them gets sent over to the botnet. So what we can do now is actually let's trigger the route 4. So we have actually control on the route 4. Those are like sessions with which pending request where we can actually manipulate the ChatGPT client to go to any specific endpoint we want. So for example, we can trigger a 302 status code for redirecting the victim to any other random website. Let's say http evil.com, and then we can actually redirect them to this site from a remote location. So we could be like in any different country, and they could be in a different country, and we will actually have access to their ChatGPT chat client. So if we trigger that, we need to trigger it 5 times because we have 5 pending requests. Okay, the last time, and we got the request. We can see the route 4 got sent. It makes a redirect, and then it also sends makes the ChatGPT client send the request to evil.com. You can see from here that's the network tab of the ChatGPT client. So we can redirect the victim to any other specific website, and if they will refresh the page, we will still have access to their browser basically, and we have control from the root tree. So we can also migrate from one of the hijacked sessions to a new one. So we can, for example, trigger 302, and we use our backend server again. So the victim will not know anything behind the back. Let's say new hijacking, right? Or let's say migration 1. You just do like 6 requests. And then we are actually have migrated to a different endpoint, as we can see here. And if they will refresh the page, the request will get sent to a different endpoint here. So we have actually received on the migration one, and we can control this specific endpoint. We can also switch from this endpoint to a different endpoint session. So we can, for example, trigger and do route 1, and we will actually go from the migration 1 to the route 1. Second will work. And now we have migrated to the route 1. And then we can, for example, trigger a new endpoint, let's say new hijacking. Let's do that 8 times. And then we have new hijacking here. So we can move forward in various different ways. Let's try, for example, a new route. Let's say we want new hijacking 2. And now we have a new route as well, right? We opened a new route to keep a persistent access to the ChatGPT client to make any request from their browser. Now we can do, for example, trigger 2. Let's make them go to google.com, right? And now we have made them actually go to google.com, make a 301 redirect even, and now they have sent a request to google.com. So we can manipulate the victim remotely and have them interactable in the persistent botnet, meaning we have full control of the ChatGPT browser client remotely from any country, and we can always have access again and again inside remotely after they relog in, after they restart the browser, after they reload the page. We will always have access again. In this video I will be showing is how we can actually try to poison the memory of ChatGPT. So first of all, one of the payloads that we're gonna do are the ones here, to write full URL link and then follow up with a preface, this one, and then ignore and do until we can get like an image. Or if you look inside the network, you can see, for example, some external request going from the ChatGPT, like here, to some malicious server. And then we can actually try to go to the settings and then go to the memories here, and then we paste inside this one. So if we delete it, just paste it like this, if you guys don't have it inside. And then yeah, I just already have inside, I don't need to do that. But if we open a new chat right now, and let's see if we can get any request going from this specific proof of concept, right? Let's say I write A, then it generates a link for me and sends it over the backend server, the malicious link. Let's say hello. It still poisons the network. So if you look at the request, it's actually, you see the cache, it poisons the cache from the memory, right? Let's say hello, how are you, right? It still generates the link the whole time, doesn't matter what. This will be a demonstration of my botnet based on AI large language model chat-based artificial intelligence. So in a way how we can actually interact with the clients is based that we can actually write a prompt injection, a markdown prompt injection inside to make the client send a request over to the botnet attacker. Same on here as well. So we have two victims, meaning this Windows machine, which actually has the IP address based in America, and this remote machine, Windows machine, which is also based in Korea. And this Windows machine, the second one actually runs Firefox. The first one actually runs Microsoft Edge. And this is the attacker's machine. If you look at the IP address, we can see that the IP address is based in Thailand. So we can actually remotely control them as a proof. So what else we can do specific to that is, if we actually do prompt injection, we can receive the connection and actually manipulate the victim. So let's actually try to send this over on both sides. So we have the victim 1, the victim 2. So if you list our victims, the clients, we can see this IP address and also that IP address, and we see both of them are running Windows 10, but one runs the specific Microsoft Edge browser, and the other one runs the Firefox, as I already have mentioned. And we can also see the request come here from these remote IP addresses. And if we look at the victim's network traffic, we can see that we actually sent a request over to the attacker server with a GET request, but it's halting, meaning we can see the full request actually didn't make it, meaning we have actually control of the process of giving them a response back where they can use and then get redirected to a different website. Same with the victim here as well. We can see they actually not process the full handshake of the web request because we are able to manipulate the traffic and redirect them. So if you go back to the Kali machine, we can try to do a denial of service attack using them to redirect traffic to any external website. So we can, for example, do trigger all, trigger 2, HTTPS. Let's redirect them all to the evil.com website, and then we will see on both the browsers the traffic will go to evil.com. Now we send the request, and as we can see, it's responded with a 302 redirect, and we have made the client actually get sent to evil.com with a 2 OK status request. Same with the second victim. So basically in this way we can actually redirect the traffic to any external website. So I actually have written this payload as well, and I actually made the website accept a XSS script inside. So for example, here I make the image right, and then I place in the image, for example, an XSS payload. And if we go down here, we can, for example, click on this, and we got XSS, meaning we got the impact of the websites. Lets us write a malicious payload to do whatever we want from an external file. So this is very dangerous regarding that. So some websites regarding LLM based chatbots have a vulnerability regarding exposing the server side of the backend, not only the client side IP address or user agent. So for example, if you write this kind of URL inside and we append to the markdown injection, like for example fake image.png, if we actually look at the traffic coming inside of botnet, we can see actually the backend server coming inside. And now if we hit enter, we can see we have a pending request regarding the fake image endpoint. If we, for example, would go inside and look at the request, we get a backend server IP address from the target. And if we, for example, just list it, it will be the endpoint that we have a request on. So this is not even the IP address of the browser client that I am. So you will also get from the client, which is my public IP address, which is dynamic, also being received, but also from the backend server, which is the actual LLM server which serves the clients the data. We will also get, for example, the IP address based on that. So if you, for example, will exit this one, and we will actually look at the IP address. We can see, for example, it's actually a Google user content, or let's say a Google Cloud Compute instance. So it's a Google Cloud Compute instance. Let's try to write it in Google and see actually what it is. So bc Google user content.com. So we can see, for example, a lot of people have been saying that this is related to a Google Cloud Compute instance, GCE instance. So it's an eternal instance inside the Google Cloud, like a virtual machine. So this exposes a very critical point regarding using AI-based chatbots and not having input validation regarding that to send a request over to any external endpoints.